Another one that is particularly interesting to me is it's not portable. Now, this interests me because, for those who don't know, I'm a long-time FreeBSD developer. Systemd is aggressively Linux-specific. It uses a whole bunch of Linux-specific process maintenance hooks that just aren't present on other systems. And so if it becomes the sort of established way to manage services, it runs the risk of isolating the other platforms that don't have those things. But it gains a bunch of really important functionality from those things. C groups is a really interesting thing. You could argue that it should stick to more Unixy interfaces doing these things, but the reality is that Unix is dead. So Unix was all about maintaining portability across a pathologically diverse range of platforms. When the Unix notion came out, when POSIX first showed up, what it was there for was to make it so that if you wrote code on 4.3 BSD on your VAX, I don't know if POSIX was around at that point, but it was not too far off, it would also run on SunOS and AX and whatever digital Unix was called at that point, and so on and so forth. Like, there was just these enormously disparate range of Unix platforms that things could run on, and so everyone kind of needed to agree on how to do that. These days, I think you've basically got Linux and some rounding errors. I'm sorry to all of the Solaris devotees out there, and I'm saying this as someone who has spent a large amount of his time and knows a significant amount of his career to FreeBSD. FreeBSD is no longer in a position where it can go, hang on, we should do this with an interface, because the entire Linux community would just go, I don't care. Whereas Linux can go, okay, here's C groups, take it or don't. It's an interesting position to be in. So we've gone from this pathological diversity to a pathological monoculture, where one platform can effectively dictate what the terms are. Systemd gains a great deal from using things that are not Unix. And one of the things that I pointed out when I first gave this talk is that this doesn't have to be a net negative, because it means that FreeBSD and the other projects could also feel similarly liberated and try and create whatever they wanted to without having to go, hang on, what does Unix think of this? So, and C groups is the thing I keep coming back to with this. C groups is a really powerful mechanism for creating manageable groups of processes. I mean, FreeBSD came up with jails ages ago, but when I look at jails, they're a lot less flexible and a lot less granular than what you can do with things like C groups. Another thing that I think that Systemd gets really right is the notion of user-level units. If you want to do a user space daemon, as in a daemon that starts up and runs as you, without you having to become root to install it, on FreeBSD, it's really hard. You basically have to write a shell script that's then going to sudo su as you and do all that kind of stuff. With Systemd, I can just drop something in a directory in my home directory, and if the thing's set up right, it just starts. I mean, the other way you can do that is to play around with cron, but playing around with cron can be fun. So it all comes back to change. Systemd represents a large amount of disruptive change, which brings us to the actual tragedy of the piece. So yeah, people have a complicated relationship with change. I like to say that nerds especially have a really complicated relationship with change. We love it to pieces. Change is awesome when we're the ones doing it. As soon as change is something that's coming from outside of us, it becomes untrustworthy. And it threatens what we think of as the familiar. People like me grew up with a notion of, init runs RC and RC runs a bunch of shell scripts and then the system works. And that familiar might be good to us because we understand it. It's our comfort zone, it's what we're used to. But I think at this point, like a system bootstrap that relies on shell scripts and relies on understanding how those shell scripts work and interact and are ordered is kind of like the old tired old blankie that we maybe should have handed off about 20 years ago. And systemd represents change. And it represents a really disruptive level of change. And it represents change that was pushed on us by people like Leonard Poettering, whose ability to have sympathy with the people who he's asking to change doesn't appear to be the greatest. But what this leads to is a knee-jerk reaction. Because the lack of sympathy isn't just on Leonard's side. The reaction to systemd got a little bit over the top in some places, I think. Abuse is not cool. No one needed to send death threats to Leonard Poettering over a piece of software. And it's not just abuse, contempt is not cool. And this was one of the things that I really wanted to ram home when I gave this talk at BSDCan. FreeBSD should not be proud of the fact that we don't have a systemd. We should see that as we're lacking something. Like, we stop if we're mocking the fact that Linux has systemd and all those poor Linux users with their terrible software, then it means that we're treating it as a joke and not as a source of ideas. And that doesn't just apply to FreeBSD, it applies to pretty much anyone who sits there going, oh no, systemd's terrible. It's like, no, look at it a bit. And one of the biggest problems that I had with the FreeBSD community on this one was things like this. Because to me, this says on behalf of my community, come join FreeBSD, we'll never change. We refuse to move forward into the future. Anyway. And so really what I want people to do when they look at something like systemd, whether they like it or whether they don't, and especially if they don't, is why. Why did systemd show up? Why is systemd important? Thinking about that means that you suddenly go, hang on, so is systemd solving a problem? What problem is it solving? Could I solve it better? Because one of the solutions, if you don't like systemd, is to go and make your own. At the very least, you're going to find out how much fun that is. And then another angle on this is that it's not just about us greybeards. The next generation of people who are coming into IT, coming into software engineering, coming into systems administration, they don't necessarily think about the systems they're running in the way that we do, that I do. They see a lot more APIs in the sense of like web APIs. Like 20 years ago, me going, oh yeah, I can spin up a Unix machine by punching a HTTP API on a bookstore. That would blow me away back then. And also things like containers. Thinking in containers ends up making, you end up thinking quite a lot differently to thinking in not containers. So on and so forth. And so this brings us to the last bit. What does systemd have that we could learn from? Or what does it offer us? So this is a section in the original talk where I basically told a bunch of BSD people what they could do if they had something like that. But I think there's a bunch of interesting, like if you go up to the higher level of what systemd has, there's a bunch of really interesting stuff to think about. Messaging transports. Systemd makes heavy use of dbus. I'm not a big fan of dbus, but I am a big fan of messages. Apple uses Mark to do the same kind of thing. One of the things that I told the BSD people was basically we should write our own message transport. My version, if I were to write one, would be kernel resident rather than user space. And it would allow a lot more sort of security and authentication and access control elements on the actual bus endpoints. But you people can write your own. Because once you've got a message transport, it's a lot easier to write an RPC framework. And the question is, why do you need this? And the answer is because if you need a leveling mechanism to make the kernel and user space operate at the same kind of level as far as the code above them is concerned. You don't want to know whether a particular service that you're talking to is handled by the kernel or by user space. You just want it to happen. You want to be able to send out an API request that says, okay, network interface, take this IP address, and just have it happen. You don't want to have to worry about, am I talking to the kernel or not? The other thing that systemd gives that a lot of previous systems didn't give you was a proper service life cycle. As I said, Windows had this from inception. macOS sort of organically grew it, and then once they came up with LaunchD, sort of massively pushed towards it. And does this without you having to install one of several different systems that all work differently, like OpenRC or Runit or SupervisorD or any of these ones. Automation via API sounds blithe, but once you can automate the setup and configuration of a system through an API that isn't sort of having to shell out into system calls or anything like that, you've basically written most of what an appliance vendor would need in order to make a really good appliance. So you could think that things like OpenWRT could use it, but then in my case, I used to work for a company that made large storage appliances. It would have made our job a ton easier to have that kind of thing. And I think the last really important thing that things like systemd enable through the use of things like C groups and stuff like that is containers. I think containers are really interesting, not because I think that they are the savior of security or anything like that, but just because they provide you with a way to encapsulate things in a way that's quite cool. And so systemd providing the system layer gives you a more consistent platform for doing that kind of stuff. And the barrier to entry for building something on top of this like an appliance is massively reduced. But again, systemd doesn't have to be the only implementation of this. Go and explore. But moving on, I think that the way systemd names devices is actually really good. And I say this as someone who used to spruik the FreeBSD notion that every Ethernet drive should have its own name. And while I also did not like the Solaris naming scheme of like C0, T0 for disks, I think that having consistent names that are generated on physical attributes of the device is a lot better than having them named after what random order they happen to show up in. I also think that systemd's model of logging is really good. Binary logs are not a bad thing, as long as you have the tools to pull them apart. But having append-only logging in a system like that, especially append-only logging that can be shipped off somewhere else easily, is, I think, very handy. But the other thing is that with containers and a whole bunch of other things, you get a new model of an application. An application no longer has to be a single binary, or a single binary that starts off other things. It can be an encapsulated series of things that are managed as a unit. I think that's really powerful. I think it would be really interesting also to look further on at how you would do a macOS-style application on a platform like Linux, being able to provide a lot more feedback from the hosted system about what's going on so that it can react to it. So, at the beginning of this talk, I showed the Wikipedia definition of tragedy, and it mentioned that it was causing catharsis in people. So, the definition of catharsis, meaning a purification or cleansing, the purification and purgation of emotions, particularly pity and fear, through art or any extreme change in emotion. What I hope that this talk has provided is a removal of fear, and particularly a removal of pity of systemd and the people who actually use it. The world is changing around us, and we can either get with the change or we can try and resist it.